This short video is an introduction to the 8D problem-solving process and specifically D2 problem definition. The 8D process goes through 8 steps that must be followed sequentially, 8 disciplines D1 through D8. In this specific video, we'll talk about D2, the second step to define the problem. When working this step, we have an objective, and that objective is to describe the problem in precise terms. The actions here are to collect the information, the data, and the facts, asking a lot of questions to help us define the problem, such as who, what, when, where, how much, how many. This information, when combined together, helps us to understand the problem in precise and concise terms. By concise, we mean that the problem definition should be very, very clear, to be done in just a few lines in order to help us to understand exactly what problem we're trying to solve. There are many pitfalls along the way. We want to make sure we describe the problem in measurable terms. Specify the problem by describing it in specific terms with facts and with data. In doing this analysis, always speak with the data. Don't say your opinion, say what the data says. The poor problem definition leads to symptom resolution rather than a root cause solution. So if we define the problem poorly, then we end up fixing symptoms that may or may not take care of the underlying problem. It should answer these questions of who, what, when, why, where, how many. And there's all kinds of varieties of 4W, 2H, and 5W, 3H. What's important is to work through a set of established questions to help us define specifically what the problem is. So if we say what, we want to know what is the problem, how the problem physically appears, what are the dimensions, what are the size, who sees the problem, who detected it first, who is involved, include all the people concerned, all the people with hands or eyes on the product as it goes through the process. Where is it observed? Very specifically, not just in terms of macro geography, but very, very specific terms, as specific as we can be, where the problem is observed and where it is known to occur. When did it happen? With what frequency in measurable numbers? How many? What is the quantity of the problem in percentage and number and measurement? How can we measure it? How can we quantify the scope of the issue? And then, of course, how much? In problem definition, good problem definition is critical to determining the root cause and does not place blame. It avoids suggesting solutions, like saying, problem happened due to. If you use a phrase like lack of, insufficient, or due to in the problem description, your problem description is incorrect. It is useful in this to think about determining and defining what is and is not. There's a very good analysis method called is not analysis, which I don't address here, but can be very, very useful in this step. But the problem needs to be described and defined in very objective terms. The problem statement should be from the customer's viewpoint. This is important. Don't describe it in internal terms unless it is strictly an internal problem. If possible, describe it from the customer's standpoint and then start to do the analysis. The problem statement has to be clear and concise, one sentence, but should be formed only after collecting all the available data to define the problem. As the saying says, a problem well defined is a problem half solved. So, the problem statement needs to consist of an object plus a concern plus the quantification. For example, and I know this is wordy, 20% of Tuesday's first shift production of NCAR number 3245A have a 1/2 inch to a 3/4 inch crack at the lower left corner of the strain relief hole. That is a problem, well defined. I doubt you will have many cases you can define it that closely in those terms, but that's an example. Problem definition data collection is for initial information before the next step, which is containment. The team will certainly learn more information about the issue as we go on in later steps. It's okay. We can go back and update D2 as we learn more information. Operational definitions must accompany the problem definition. We need to be very, very careful. What does failure mean? What is bad, quote unquote? How much is large? How much is out of spec? What is improper? It is very important not to use these nebulous terms in the problem definition. We need to define everything as much as humanly possible. Good or bad definition. If we take the example, lack of parts caused 10% miss in sales for May. This is bad. This assumes the cause of the problem in the statement. Lack of parts, they assume, is the problem causing the 10% miss in sales. Marketing delays cause projects to be 2 months overdue on average. This places blame and assumes the cause, that it's the marketing delays that cause the projects to be 2 months overdue. This is not an acceptable problem statement, problem definition. Impulse coil failures for all 3-phase transformers at Walkup LLC increased from 10,000 PM in Q1 to 15,000 in Q2. Okay, we could parse this and criticize it, but in general, it's a pretty good approach. It answers the 5W2H. Okay, so to recap, as we look at D2 with the problem definition, remember we're going to describe the problem in precise terms. We're going to take actions here to define the data and the facts to collect who, what, when, where, how many, and how much. And the result, we're going to have a precise and concise problem statement.